Okay. So someone giving me the name of that compound there. Joan Natkunda.
Potassium chloride.
Thank you very much. We know that ClO3 is chlorate, and then K is potassium. So the name is potassium chlorate. Okay, can I get the next one?
Yeah.
Yes, please. Carla, can you give me the next one?
Potassium iodide.
That is potassium iodide. Thank you very much. We have K, which is still potassium, and then I is iodide. So the name is potassium iodide. I hope all of us are taking notes. I'm going to go to the next one. Can I get another person putting up their hand?
Let's have Johanna.
Sodium hydrogen carbonate.
Sodium hydrogen carbonate. Thank you very much. So we know that when I write Na, that is sodium, and then the HCO3, or that one is a radical that we call hydrogen carbonate. Okay, I'm not going to go through that whole list, but I hope we get a clue on how to give the name of the compound by using the formula of the element and then later on the formula of the radical. Can someone give me the name for number 7 and we'll stop on that one, then the rest of us need to complete all the others. Number 7.
Let's have Tina.
Calcium chloride.
That is calcium chloride. So we have Ca, which is calcium, and then the Cl is the chloride. Of course, Cl is chlorine, but I hope we still remember that when chlorine gains electrons, we change the name and it becomes chloride. So can I have any questions as far as naming these compounds is concerned? Because I said I will not go through all of them. Can I have questions as far as naming the compound is concerned?
Ntongo's hand is up.
Yes, Ntongo?
Teacher, how do you name the eighth compound? Because it looks different.
Why does it look different?
Teacher, I thought it would be magnesium hydrogen carbonate, but then there is a 2 at the end. And I know
Yes.
compounds that have a 2 end with died.
Not really. Your first name is right. We shall explain where that 2 comes from. That 2 is supposed to be the valency of magnesium. After exchanging the valence, we put the hydrogen carbonate in the bracket, then the 2 is placed outside. Of course, we'll be explaining why we put the 2 outside later on, but your name is right.
So what do you do not to get confused that that's a valence or not? I don't know.
So we have said that we are using the symbols of the element and then the symbol of the radical. Don't consider the letters, the numbers outside yet.
Oh, okay.
So the symbol that I see here as Mg, that is supposed to be magnesium. And then HCO3 is the hydrogen carbonate. So that is what we do when we are naming. We just pick the symbol of the metal and then the symbol of the radical, and then we give the name. Is that okay,
Yes,
Angel?
thank you.
Okay, can I have any other questions on giving names?
Denise, are you okay?
Yes, teacher, I wanted to know. So you mean that valencies are exchanged even when radicals are coming together with elements?
Exactly. We exchange valencies when we are writing the formula, just the way we did when we are doing bonding. So we'll still exchange the valencies. Any other question?
I don't see any hand up.
Okay, so we are going to move on. I hope all of us will take through and complete all those names there. Can someone give me the name to number 13? What is the name for number 13?
Jovia,
Sodium phosphate.
Sodium.
That is sodium phosphate. Thank you very much. Na is sodium. Then PO4 is phosphate. So I hope we can be able to identify the name of the element. We are going to look at question 2. Petra, your hand is up. Do you have a question?
Yes, teacher. When like they give us the final compound, have like you said sodium, the last example you gave, have the valences already been exchanged?
Exactly, they have already been exchanged. Now, all the examples that you have there, we are writing the finished chemical formula of the compound. And I said that when you're writing the chemical formula, we use the symbols and valencies. So, already the valencies have been exchanged from those examples above.
Okay,
Okay,
thank you.
I'm now looking at question 2. I've said it is your duty to go through all those numbers, and the more practice that you do, you get better at this work. So question 2 says, state the radicals present in each of these compounds. I need answers to those questions. Though I am seeing the same people putting up their hand. I need to, Rebecca.
Number 1, the radical present is hydrogen carbonate.
Thank you very much. It is HCO3, which is a hydrogen carbonate. Laura, can you give me the answer to Roman 2?
The radical for Roman 2 is HCO3 in bracket 2.
I want the name. What is the name?
Hydrogen carbonate.
It is also a hydrogen carbonate. Thank you very much. Can I get Roman 3? Roman 3, I need someone who hasn't given me an answer yet. Okay, Petra?
Roman 3 is a nitrate.
That is a nitrate, NO3. Can I get the radical for number 4?
let's hear from Para.
Ammonium.
Okay, someone has given me that there is ammonium radical. Can I get the other radical in number 4? Because both of them are radicals. I hope we've taken note of that.
Let's hear from Melissa.
Thank you very much. Now, if we remember the list of radicals that we gave, I don't know if we talked about, but ammonium, that is NH4, is a radical and we call it ammonium. And this radical has a positive charge, or it is positively charged. Now, because it is positive, it can combine with the other radicals that are negatively charged. For example, it combines with the sulfate to form a compound called ammonium sulfate. So it is the only radical that can combine with other radicals. I hope we've taken note of that. So in number 4, we have two radicals. We have the ammonium radical and then the sulfate radical. I hope that's okay. Can someone give me the answer to number 4? Which radical do we have there? I need someone. Yes, please.
Answer to number 4 is
Chloride.
That's a chloride. Thank you very much. Number 6. This person has background information. Joanna, can you give me the answer, Johanna?
Iodide.
Iodide. Okay, number 7. Someone else for number 7? Melissa?
Permanganate.
That is permanganate. Thank you. Number 8.
Wait, teacher, I don't understand why number 7 is a permanganate.
So number 7, we have the compound which is KMNO4. So the whole of this is the radical that we are talking about. And that radical is called a permanganate radical. It has another name which we can say manganate 7. Or you can call it the permanganate radical. Is that okay?
Can be manganate permanganate.
Yes, thank you, teacher.
Okay. Any questions on number 2? Because I'm moving to number 3 now.
Number 4.
Can someone give me the radical for number 8, Roman 8? Which radical is that? Jovia?
Peroxide.
That is a peroxide. And I hope we know that a peroxide is the O2. Of course, it has a charge of -2. That's why we don't call it oxygen, but it's supposed to be a permanganate, a peroxide. Sorry, peroxide. Okay. Any questions on number 2? Okay. Can we go to number 3? Nimanya, can you read for us question 3?
I have a question.
Number
Okay,
2.
ask your question, then you read the question as well. What's your question?
I'm so confused about number 7, like part 7.
Mm-hmm.
I don't what okay, it's called is the radical called a manganate.
Yes, please.
But why? Why can't we use the elements that are given and we call it
Okay.
like
Do you know what is the name for an element that has a symbol of Mn? How do we call that element?
Manganese.
That element is manganese, isn't it? So when
yeah,
manganese combines with oxygen, we get a radical that we call a manganate or permanganate. Nimanya, is that fine?
yes.
It is still coming from the elements. You have Mn, which is manganese, but this time it is not manganese alone. It has combined with oxygen. So the radical is called a permanganate or a manganate, meaning that it has oxygen there. It is not manganese only.
Okay.
Can you read for me question 3?
Calculate the number of nitrogen atoms present in the following compounds.
Okay. We talked about that during the previous lesson. This topic requires a lot of practice from us. So, can any one of you remind me how do we get the number of nitrogen atoms in that compound? By the way, what is the name for that compound, Roman 1? How do we call the compound?
Barium.
Can someone give me the answer? I need someone who has not answered yet. How do we call that compound in Roman 1? Because it is now important for us to be able that when I find the formula, I should know which compound it is. Yes, Rebecca.
Barium nitrate.
Barium nitrate. A is barium, NO3 is nitrate. So that is barium nitrate. Mwebaze, do you have a question or an answer?
No, I wanted to answer that question.
Okay, please give me the answer.
I think nitrogen has 2 atoms.
It has 2 atoms. Do you mind explaining to us how you have got the 2 atoms?
I'm not sure really.
Thank you. Can I get any?
So it was supposed to be 2 times the 1 because there's 1 and a hidden 1 in that nitrogen. So when you get 1 times 2, we'll have 2 nitrogen atoms.
Thank you very much. So if you look at the formula here, we have nitrogen here. And that nitrogen, when you don't write any figure, it means it is 1. Now, all this nitrate is in brackets and it has a 2 outside. So this 2 multiplies whatever is inside the brackets. So that means it is 2 times 1 for nitrogen and then 2 times 3 for oxygen. But our question is looking at only nitrogen, so it is 1 times the 2 outside, giving us the 2 atoms for nitrogen. I hope that is fine for all of us. Can I move to Roman 2? Mwebaze, I see still your hand is up. Do you have a question? Yes.
I don't get why you multiply.
Now this is supposed to be a little bit of math, I think. When I have 2, probably X, and I have put it in brackets, then I put a 2 outside. How do I get the total number of X's?
You multiply.
You multiply.
You will multiply. So when I have this, though that 2 is that side, it means I have NO3, and all this is in brackets, I have that 2 in front. Though we don't write it there, but it is as if that 2 is in front of this. So it multiplies whatever is inside the brackets. That means it is 1 nitrogen atom here times 2. Oxygen, I have 3 already, so that is 3 times 2, which gives me 6. Is that fine?
Yes, thank you very much, teacher.
Yes, teacher.
Okay, I'm moving to Roman 2. Can someone give me the answer to Roman 2? Helen, I see your hand up, Helen.
Teacher, I think it's ammonium sulfate.
Thank you. The name is ammonium sulfate. How many nitrogen atoms are there? We are only looking for nitrogen, but of course, as a student, as you do your revision, it is important for you to look at even all the other elements. Can you find how many hydrogen atoms are there? Can you find how many sulfur ion atoms are there? But our question is looking at only nitrogen. Faith Nikisa, can you give me an answer?
There are 2 nitrogen atoms.
I hope all of us know how she got the 2. So here, still, nitrogen is 1. We don't write 1, but we should know that once you see that symbol, it means there is 1 atom. There is a 2 outside the brackets, and it is multiplying nitrogen, it is multiplying hydrogen. So our nitrogen is 1 times that 2 outside to give us 2 atoms of nitrogen. I hope that's okay. Ntongo?
Teacher, it's okay to give an answer to the next question.
Okay. Kara?
The same.
Dav, can you give me the answer to Roman 3? First, give me that. Oh, we have already named that compound, but I need the number of nitrogen atoms there. Dav, are you there? Carla, can you give me the answer?
4.
It's 4. Can you briefly
Nitrogen.
explain to us? Briefly explain.
We multiply the 2 because we have 2 molecules of barium nitrate. We multiply the 2 and the 2 outside the radical to get 4.
Very much. We said when you write a 2 in front or any figure in front, it is as if you have put all these in brackets. So it multiplies the barium, it multiplies the nitrogen, it multiplies the oxygen. We don't usually put the brackets there, but you need to know at the back of your mind that any figure placed in front of a chemical formula multiplies all the elements in that chemical formula. So when we have a 2 in front of barium nitrate, it means that our nitrogen atoms, as we identified them in the first compound, it is 1 times that 2, but now times that 2 again. So we multiply by 2, which gives us 4. I don't know if I have questions. Any questions? Because we are moving ahead. Johanna? Yes.
So that 2 that is outside the brackets, do you still
if they wanted to know how many barium atoms are present, would you have to multiply that too?
Exactly.
The
So for me to get barium, barium is 1 atom, but there is a 2 in front, so it is times 2, which gives me 2.
So the one outside the brackets does not count when you're looking for barium.
The one outside the brackets, I don't understand.
That too.
This one here, this one.
Yes.
It doesn't count because it is only on the nitrate. The brackets you see, they start from here and then end here. The nitrate is out, so it is not part of this two. This two is only affecting nitrogen, it is affecting oxygen, but not barium.
Okay, thank you, teacher.
You're welcome. Bonita, can you give me the... Bonita, can you give me the answer to the next question? I see someone's hand up. This is... Can I have your question? Yes, please. Nyakukira, can you ask your question?
Oh no, I
Or
wanted
give
to
me the
answer.
answer? Oh, yes, please. Give me the answer.
Okay, so that's ammonium sulfate. And the number of nitrogen atoms are 6. Number 6.
So there are 3 things that we have so far talked about. Being in position to identify the radical, naming the compound, and then number 3, identifying the number of atoms present in a given compound. So we are saying that for number 4, there are 6 nitrogen atoms. I hope all of us can be able to get that. Have ammonium, then sulfate, and there's a 3 in front. We said once you put this, it affects all the compounds. So for nitrogen, it was originally 1 times 2. But we have 3 of them here. So we multiply by 3 again, and that gives us 6. I hope that's okay. That information will be very important when we begin to balance equations. It will be very important because we balance equations by writing figures in front. So when I put it in front, what does it mean? How does it affect the elements in the compound? I can receive a few questions before we proceed. Any questions? Yes, Glenn, I can see your hand up. Do you have a question?
Yes. On the blackboard, you've written an equation. So I just wanted to ask, the 2 at the bracket, does it only those that are like influence, that being the NH4, or it also affects the remaining SO4 and O?
It doesn't affect. Now, if I put these brackets here, it means they only affect whatever is inside the brackets. Anything that is outside the brackets is not part of what is inside the brackets. So my 2 outside the brackets only affects nitrogen and hydrogen, but not the sulfate and the other side. Is that okay?
Yes, thank you.
Bonita? Bonita? Now, if you can see my screen, we are moving on to the next subtopic, and that subtopic is what we have probably been discussing all along, but now we are going to begin the actual writing of the chemical formula. So we have a few rules that we need to follow for us to be able to write the chemical formula of any given compound. I want someone to read for me the rules that we follow. Anyone that is ready to do that? Favor, can you do that?
Yes, teacher. Symbols, radicals, and valences are used when writing formulae of compounds. 3 steps are followed when writing the formulae of compounds. Write the symbols for elements and radicals. We write the symbols with valences above and on the right-hand side of the symbols. We write the symbols interchanging the valences and writing the numbers except 1 down and to the right. If there are common valences, do not write the numbers. If one of the valences is a multiple of the other, consider reducing it with respect to the other valences such that the ratio is still retained.
Okay, thank you very much. That is information that we should all read and understand so we can be able to write chemical formula. Number 1, when I tell you the name of the compound is sodium chloride, for example, can you write the symbol for sodium? Can you write the symbol for a chloride? So that is supposed to be step number 1. If they have told me the compound is sodium chloride, step number 1, I write the symbol for sodium, which is Na. Write the symbol for the chloride, which is Cl. Then step number 2 says we write the valencies of the elements on the top right-hand side of the symbols. Can one of you remind me what is the valency for sodium?
1.
What is the valence for sodium? It is 1. I'm still going through this, but I will have a few questions about. So we have the valency of sodium as 1. What is the valency for a chloride?
1.
It is also 1. Faith, do you have a question?
1.
No, teacher, it's
Okay. So, step number 1 was write the symbols, which I did. Step number 2, write the valencies on the right corner, that one up there where I have put them. Then step number 3 says we interchange the valencies and then write them. Of course, we write it if it is not 1. So, if I exchange that, I have 1 here. Exchange this, I have 1. Exchanging means that the valence for this element this side becomes the valence this side. Then the valence here goes that side. And then after I have exchanged the valences, you write the formula of the compound. Remember, we don't write the valency of 1. So, sodium chloride will be just that. Now, as just reading through the steps that we follow, can one of you remind me what is the valence? When we talk of valence, what does it mean? What is valency? Michelle?
Valency is the number of atoms left to make an element stable.
The number of?
Atoms left to make an element stable.
Number of atoms? Not really. It's not number of atoms, but thank you for trying. Buinza, can you give me the definition of a valency?
Valence is the number of electrons needed to make an element, to make an atom stable.
So you need to refer to what we looked at during the last season. We said valence is usually the number of electrons that an element can lose or gain or share in order to obtain a stable electronic configuration. And remember, we said that here, when we are writing chemical formula, we need those valencies. Of course, during our previous lessons, we said that when you write the electronic configuration of any element, you should be able to determine the valence. And don't expect us that when I tell you, write the formula of sodium sulfate, I'll give you the valencies. You are supposed to know the valencies. So one of your duties as we go through this topic, take your time to read through. How do I get the valencies? For the elements, it is easy. If you know the atomic number, write electronic configuration, and then from that electronic configuration, you'll get valence. But during the previous lesson, we also gave examples of radicals and their valencies. So it is important for each one of you to find the valencies. So we have the table there. I hope we can see that table. It is giving us examples of elements with a valency of 1. Can someone read for me? Which elements have a valency of 1? Examples.
Potassium, sodium, silver, copper, hydrogen, chloride.
Okay. Another person reading for me. Valence 2. Examples of elements with valence 2. Faith.
Calcium.
Go ahead. It's okay.
Elements with valency 2 are calcium, magnesium, barium, zinc, iron, lead, copper, mercury, oxygen, sulfur.
What do we note about copper from those 2 columns? What do we note about copper?
We note that copper has 2 valencies, 1 and 2.
Thank you very much. So we know that there are some elements that use more than 1 valence. And one example so far is copper. Okay. If you look at lead, it is also in that same category because it has a valency of 2, and then in valence 4 we also have lead. Someone reading for me examples of elements with valence 3.
Elements with valency 3, aluminum, iron, nitrogen, and phosphorus.
Thank you very much. Another person reading for me valence 4.
Carbon, silicon, lead.
Okay. Karabo, do you have a question for me?
No, it's okay.
Okay, I'm receiving any questions before we look at a few examples because our time is almost up. We are going to look at a few examples how we write formula. But any questions about what we have so far discussed? Beijuka, do you have a question?
Yes. For the elements with more than 1 valency, how do you know which valency to use?
Thank you very much. We are going to talk about that. Laura, do you have, Laureen, do you have a question?
Yes. For these elements which have 2 valencies, that means like the ones which have 2 valencies are not in the 20 elements which we list in the periodic table.
Most of them are beyond the first 20 elements, most of them. Of course, we have some few in the first 20 elements. For example, carbon sometimes uses a valency of 2 and 4. Even phosphorus sometimes uses a valency of 3 and 5.
Okay, thank you, teacher.
I think I need to handle that before I continue. So someone was asking, how do we know it is using a valency of 2, it is using a valency of 4? I hope you can see the board. We can write lead 2 oxide, lead 4 oxide. I'm very sure those of you that have been checking through the textbooks, you have come across that kind of writing. Now, that is an indication that an element has more than one valence, but they are specifying for you. If I say lead 2, it means now I'm going to use a valence of 2. If they say lead 4, it means it is now using a valence of 4. The same applies to iron. I think yes, iron also is there. So I can have iron. So that is how we differentiate the valence used. I can have iron 2 chloride and 3 chloride. So once you see those numbers there, those numbers are talking about the valence used at a given time. I hope that answers the question of someone who was asking me, how do we know this is now the valence? That is how we know from the name. Bejuka, do you have a question for me?
No.
Okay.
You answered the question. Thank you.
Okay. Any other questions before we can look at a few examples?
Excuse me, teacher. Excuse me, teacher.
Yes, please.
Do the different valencies come because of isotopes?
Not really. The valences are not related to isotopes at all.
I don't understand the difference.
We said that valences are related to the number of electrons either an element loses or gains in order to become stable. So if you're saying that it has like iron 2, that means in that case it has lost 2 electrons. If it is iron 3, that means it has lost 3 electrons. So the valences have nothing to do with isotopes. You should note that the examples of isotopes that we gave were elements that have isotopes. There was carbon, there was chlorine, oxygen, and it is not the examples that we are mentioning here. I hope that's okay.
Excuse me, teacher.
Yes, please.
Is the lead and iron what causes them to have 2 and 3? Is it because of the chloride? Because you say that the exchange valencies. So is it the chloride that gives them the 3 and the 2, or?
Now we said some of these elements fall under a category of elements that we call the transition elements, the ones in between group 2 and group 3 in the periodic table. And one of their characteristics is having more than one valence. So iron, copper, they fall in that category of elements that have more than one valence. Now, for some other elements, it depends on their ability to become stable. Some of them either, for example, lead can use a valency of 4 and it can also use a valency of 2. So that is what we can say about valencies. I don't know, I probably need one of the teachers to comment on those variable valencies.
What is the question? The question.
What's the question? No, the question is, why do some elements have more than one valence? Why do some elements have more than one valence?
Okay, maybe if I can say something about it. Like Teacher Sylvia said, we find most of those elements in the valley of the periodic table. We call such elements the transition elements. So when they are filling in electrons, most of those have what we call the d orbitals. That's why we didn't want to talk about this now. So in the d orbitals, you realize that some of those elements will lose one electron and they are still stable. Some can lose 2 and they are still stable. Some 3, 4, like manganese, which has so many valencies. So they can lose a number of electrons and remain stable because of how the electrons are filled in the d orbitals of their atoms. But the d orbitals is not for O level. Let's shelve that for A level. So what you're required to know are the different valencies of some of those elements. And there are not many. We have basically copper, iron, and manganese for this level. The rest, kindly let's keep them until A level chemistry. Thank you.
Thank you, Mrs. Kampore. I hope we've taken note of that. I'm going to do 3 examples, and the rest of the examples we are expected to take time and practice. Of course, we are going to still be at this during our next lesson, but I'm going to do the first 3 examples, and that's where we'll end for today. So example number 1 is sodium, which we have already done, but we shall repeat for all of us to take note. So we say sodium is Na, chlorine Cl, has a valency of 1, chlorine has a valency of 1. Next step is interchanging. This is 1, and then 1 also goes that side. But remember, we said you don't write 1. So that means my formula for sodium chloride is simply NaCl. I'll receive a few questions at the end, but I'm doing number 2. I think I'll stick on number 2 most likely. So, manganese 4 oxide. Can someone remind me the formula, the symbol for manganese?
Mn.
Mn.
Capital M, small n. What is the symbol for oxide?
Capital O.
So this is where we have the variable valencies, but they are telling us it is manganese 4. Can we mute? All of us need to mute our microphones. So, manganese 4, they are telling us that in this compound, manganese is using a valency of 4. I hope we've taken note of that. And when you're writing the name, the space comes after you've put that 4. So you put manganese 4 is like one word, then you put the space and write the oxide. So we have 4 for manganese. Someone giving me the valency of oxygen?
2.
It is 2. Thank you. So we interchange, and I have a 2 here. Then the 4 goes that side. Can someone remind me what do I do with those valencies?
You reduce them.
Reduce the lowest.
So they can be reduced. 2 and 4 can be reduced. What do I need to reduce them?
By 2.
By 2.
So by 2 this gives me 1. By 2 that gives me 2. And that means I'm going to now write my formula, which is Mn. We don't write 1. O has 2. I'm sure we'll come across that when we are preparing oxygen, manganese 4 oxide, and you wondered why we wrote it like that. So I hope that answers your question now. Someone has a question for me, one, and we'll end with that.
Teacher, if you don't reduce, do they mark you wrong?
Exactly, we cross that one. They should be simplified. You write the formula in the simplest form, so we have to simplify the valences if they can be simplified. So the rest of us have duties. You need to go through all these examples that we have given here, such that during our next lesson, you're only cross-checking your work. Did I do it right? Did I do it wrong? So you can mark yourself and understand better. If I don't have any questions, I need to stop there. You can have a good afternoon.
You too.
Thank you, teacher.
Thank you, teacher.
Bye.
Teacher, please remember that
Afternoon to you to put the recording in Google Classroom.
Bye, teacher.
Bye, teacher.
Bye bye.
Bye, Daniela.